Hello, everyone. We've reached the final session of Edge Impulse Imagine Innovators. What an incredible journey it has been. Over the course of this event, we've explored a wide range of topics from the latest advancement in Edge AI to practical application and innovative technologies. We've heard from industry experts, engaged in insightful discussions, and gained valuable insights that will shape the future of Edge AI. As we wrap up this event, we have a very special keynote to conclude our time together. It's my great pleasure to introduce our final speaker, someone whose vision and leadership has been instrumental in driving the field of AI forward. Yan Yongbu. So Yan is an embedded, or was, is now still is, an embedded engineer and machine learning advocate, always looking for ways to gather more intelligence from the real world. He has shipped devices, worked on the latest technologies, simulated microcontrollers, and you know what? There's even a monument in San Francisco with his name on it. So Jan's extensive experience and passion for innovation makes him a driving force in the field of AGI. Jan, thanks a lot for joining us today. We're already excited to hear what your closing thoughts and insight will be.
Awesome.
Jan, the floor is yours.
Thank you, Louis. That's almost like I've written it myself. It's fantastic. So yeah, I'm Jan Jungbo. Really great to close Imagine Innovators out. I've been working on Edge Impulse almost 6 years ago now, or for almost 6 years now. And it's been a tremendous journey. And that is all thanks to you, the community. And just to show how fast that community has been growing, in the summer of 2023, we had our offsite, and this was our whole team back then, almost 2 years ago. And we celebrated that we hit 200,000 projects on Edge Impulse. And that sounded like such an amazingly huge number. Truly tremendous. And here we are now, less than 2 years later. I just looked at the stats, and we're now at 488,000 projects already. So you see how this ramps up. This 200,000 projects that we did in basically 3.5 years of running the company. We do that now in under a year. And this trajectory is growing faster and faster and faster. And that is all you. This is unique Edge AI applications that you guys, everyone watching here on the stream, everyone in the community has been building. It is fantastic, really fantastic to see all of this happen. I couldn't be more proud. So in the next 25 minutes, we're going to show some of the stuff that we have done since the last Imagine in September. And we're going to be looking at some new stuff in the product that is coming very, very soon. So the first thing that I'm incredibly excited to announce is an update to our community plan. And this is the plan that is available to all users without having to pay. So a really big wish of mine has been to increase the compute limit. So before, we had a 20-minute per job compute limit. Now we are actually upping that to 60 minutes per job. So that is 3 times longer jobs. That is bigger models, larger models, more data, etc. that you can put in your models to build better Edge AI applications. We're also enabling GPU training for everyone in the community. That is incredibly exciting. So far, we've only been giving CPU access to people on community tier. Now we're actually enabling GPU training. So that will enable even larger models within that 60-minute compute time limit. We are also now going to give you access to state-of-the-art Edge Impulse model architectures. So stuff that we've been building internally for our enterprise customers. So these are architectures like FOMO-ID, our visual anomaly detection model architectures, and YOLO Pro, our state-of-the-art object detection algorithms. We're going to talk a lot more about these, but you will get access to all of these as a community developer. And we're also upping a bunch of other entitlements. So you'll have more private projects, more experiments, and we'll first enable collaboration on community tier projects as well. Super, super cool. We also have a project list in Edge Impulse, and I think it's really cool to see that public projects that you guys have all shared. We have over 31,000 projects already on there, and it's a great way to share data sets, best practices, etc. However, the landing page for these things looked quite dull, especially if someone didn't write a README yet. This is an example project without a README that I put together, and there is nothing really here. There's no information on what this actually contains, what this does, the types of data that we go in, accuracy numbers, etc. So we have redesigned our public projects page. This is available right now. And on every public project, you will now get a README if it's there, but if there's not, there will also be a subset of the data, so you can quickly look at what actually this data entails, information about the sensors and frequency of data, labels, accuracy numbers, and on-device performance. Because who cares if your model is the best in the world? If it doesn't fit on the target where you want to run it, it might not be a good fit for you. Super cool. Another thing that we've been working on based on feedback from the community is a bunch of new labeling tools, especially for computer vision models. So the first one of these is a new bounding box, new ways of editing bounding boxes quickly and better and more precisely. So let's say that we have a data set of chess pieces that we want to accurately label. Well, there's going to be a lot of items. So the first new iteration is that we have a new bounding box editor. So you can just zoom in now for the first time. So if you have a lot of small objects, you can just zoom right in and draw stuff. If you want to hide bounding boxes at some point, just click the little icon here and just save them to edit. The second is that we have inline editing of bounding boxes. You can just enable that through the view icon, and then you can just draw directly on stuff in the grid view. And I think that's really, really powerful. This makes stuff a lot faster. So the new bounding box editor is not live yet. It will be very soon, somewhere this quarter. The inline editing, that is already available right now. I've been using it all the time. If you quickly want to edit bounding boxes, tremendously useful tool. However, drawing bounding boxes on images just gets tedious incredibly fast. So a few months ago, we've released AI labeling. And if you've not seen it, I think it's absolutely magical because it allows you to use really big AI models to help you label these data sets. So here I have the same data set. And now I can use a zero-shot object detector, a really, really big model, to help me label these chess pieces. And this needs to happen in two stages. So first I use a zero-shot object detector to label the pieces, because this model is not smart enough to actually understand what a king and a knight, etc. is. But then I can actually add an extra step and build a multi-stage bounding box labeler straight from the Edge Impulse Studio. And the second part of this labeling block is going to be a big LLM that is then going to take the pieces found by the zero-shot object detector and then relabel them. So here I want to relabel all the pieces respond with just the name of the chess piece, and that's what I'm going to give to GPT-4o, which is actually totally capable of taking a bounding box and relabeling it. And within seconds, I have a perfectly labeled data set that is incredibly tedious to do by hand. And this integrates deeply into the rest of Edge Impulse. So if you have access to organizational data sets, one of our enterprise feature, we can look at unlabeled data that just flows into an S3 bucket. So here I have new chess pieces that maybe someone uploaded, or I got these from a camera in the field. I can now set a data source, sync data from my chess pieces project to this project. I leave the data unlabeled, and my post-sync action is run AI labeling. So run this AI labeling flow, these two stages, over all the new data that we always import. And then I can set up other stuff in my active learning pipeline, like retraining my model, creating a new version, creating a new deployment, and pushing that to my device management service. So I ran this, and now automatically data from S3 flows into the project, gets automatically labeled, and now I'm ready to retrain this model and push a new version. This is incredibly powerful stuff. So that's on the data side. We're also heavily investing in building better models. The first one is a really big request from the community. It's come up many times. The question typically is, can we have loss graphs? That's one, or other metrics. And we figured, well, rather than rebuilding all of that ourselves into the studio, can we just stand on the shoulders of giants? So we've been integrating TensorBoard into Edge Impulse Studio. It's not available publicly yet, but it will be very soon. For every model that you train in Edge Impulse, you will now, even while training, have a TensorBoard button next to the outputs. And when you click that, you'll get a TensorBoard instance for your complete project where you can see all the runs, all the loss graphs, etc., and even go configure custom stuff in this TensorBoard instance. So anything that you expect from a good sort of ops framework for your ML pipelines, you can find here right through TensorBoard. Really cool stuff. And we've been using it internally already very heavily. So excited to go, expose that to everyone on the platform. So FOMO-ID, our visual anomaly detection system. As we announced at Imagine 2024 in September, FOMO-ID actually has an HD variant now. So FOMO-ID is our state-of-the-art set of visual anomaly detection models. What I think is cool about visual anomaly detection is that it allows you to train on non-anomalous data first. So I can give you examples of here's stuff that is non-anomalous. There's nothing wrong with these things. And then during inference, I throw a new image in and will tell you whether does this look like something is wrong with the picture, yes or no. Really cool. We've launched that end of 2023. After a lot of customer feedback, we released our HD version late last year, and that is now fully available. So that is a bigger model for very small defects, large images, or complex scenes. So it can pick up stuff like the missing legs on this sensor. We already have multiple customers that use this for visual inspection and quality control. So this is battle tested, real stuff that you can go deploy incredibly fast already. And the HD version is only making the stuff better and better and better. The Eon Tuner is also getting a really big update. So we've been working hard on adding Bayesian search to this. And that allows us to go compose a search space in the Eon Tuner that runs through thousands of combinations and then very quickly prune stuff that doesn't look promising because we don't get right accuracy, etc. This way you can create way bigger search spaces and still efficiently search through these. So Bayesian search is going to be an enterprise feature only for now, but we'll see what we can open up later. Another thing that we've been adding, this will come very soon, is full support for FOMO-ID. And that actually includes for the first time threshold tuning. So what should the threshold be when I need to flag something as an anomaly? And for me, I think the most interesting or the coolest thing here is that I've been playing around with some data sets for FOMO-ID, and I count myself a relatively, experienced Edge-Impulse user. And I managed to get to about 92% accuracy on this data set by hand, by just tuning parameters. And I threw this through the new Eon Tuner. And the Eon Tuner found actually a model that was 94% accurate within the constraints that I set. So here, within the latency constraints. I thought that was really cool. And I think it solidifies the Eon Tuner as a serious tool for serious engineers. Really cool. I think incredibly useful for everyone who's doing model exploration. Another model that we announced at Imagine 2024 is YOLO Pro, our new state-of-the-art object detector. So because we can make some different choices than other typical state-of-the-art object detectors, because we are dealing with these types of industrial use cases, we actually see much smaller size than other state-of-the-art models, while still maintaining similar performance and actually being able to run on a super wide range of compute. So the smallest version of YOLO Pro can actually run on high-end MCU, and that can scale up to, highest rate of NPUs. If you want to get early access to that, scan the QR code. That program is still open, and we expect a release for everyone before the end of Q2. And this is going to be really amazing. Like anyone who's been looking for state-of-the-art object detection architecture built right into Edge-Impulse, this is going to be sort of the high-end version of what we've been doing previously with FOMO. Really cool. Now, an object detector, and I think this goes wider, but in the context of object detection, it's sort of a weird approach to these problems, because the way that you train these models is that you take one frame, right, with, in this case, cars labeled onto it, and you train your model on that, and you do inference on a per frame basis. But customers never really do analysis on a single frame at a time. They always do it on a stream of images, right? I don't throw a single picture of whatever, like a chest scan or something, and ask, can you identify cancer here? But rather, we have, here's a video feed, and I want to know, let me know if there's a new object, because I want to run some analysis over it. Or how many objects actually passed the line, because I am on a conveyor belt. Or, hey, I see that an object was not detected for one frame. Was it actually gone? These are the types of questions we have. So there's always a time series component in. We need to know what happened in the frames before. So the two post-processing things that we see the most often that we've decided to go invest in are object tracking and object counting. So object tracking allows you to keep track of objects between frames. And then rather than getting raw bounding boxes out, you will get a clean stream of objects. So you don't get, oh, here's car. No, here's car with ID 0, here's car with ID 1, here's car with ID 2. And in the next frame, we'll still tell you, hey, this is still car with ID 0, and this is still car with ID 1, and car with ID 2 is now actually gone. So this is all available in our SDK. So if you want to integrate object tracking and object counting into your computer vision applications today, we have battle tested, really efficient object tracking and object tracking algorithms. And then integration in the studio will come very soon. I'll have a video of this right after. For object counting, that actually builds on top of these object tracking. So here we can count, for example, when stuff passes a line, which is really useful if you want to count stuff in an industrial setting, or in this case, count cars coming down a highway. That is available in the SDK today. We're still considering whether we want to build it into the studio, but this is something you can start using today. And both object tracking and object counting scale over all the compute that we have. So this works even on MCUs if you combine it with FOMO, all the way up to really high-end NPUs if you combine it with YOLO Pro. So here's an example of object counting doing that. Really, really nice. So let's go take a look at how it looks in Studio. So here I have a person detection system, and that detects me. And if I want to know if this model works well, yes or no, I need to go dance in front of the camera, like I'm doing here, on my model. Now, we've added a new thing in Studio called post-processing. And in post-processing, you can upload a video, just like the one that I just did in front of the camera, and just run it over your model. So you need to dance only in front of the camera once, and then we'll see, bounding box predictions laid over. But here, I don't know. I'm still looking at the same person from frame to frame. This is all stuff that is going to be incredibly useful if I want to go test this out on my actual application. So we can just enable object tracking now. And that loads the extra object tracking post-processing layer on top of this video. And now I get person with ID 0, and you'll actually see that this person is being tracked frame by frame. And when I go out of the frame and come back, we'll detect it as a new person. So really quick to go add and verify these new post-processing layers directly from the studio and visually. And here I can do the same on another video that we found. And you can just scroll through frame by frame to look at these predictions and not just get raw bounding boxes, but actual objects. And the moment you want to save, just click save. And when you load this model, whether you do this embedded or in Linux, or in this case, in our mobile client, I now have person detection, but now actually with the ID there, and knowing that frame by frame, that is still the same person. So super quick to go add that. This also works on pre-trained models. So here I uploaded a model that is trained on a COCO dataset. So maybe I want to count the cars here. Super noisy, mostly because there's all kinds of other objects. So I can just limit it by cars. That's quick. And now I enable object tracking. And now we also smooth out a lot of stuff. So this works well. So we still see a lot of jitter on top of the picture. But if you want to count the cars coming in and out, you draw a line basically at the bottom of the video twice, and you can count it quite accurately. So this model will even work for this kind of stuff. So really quick to help you go build these types of things to actually make object tracking or object detection models really useful. So on the deployment side, we're going to be releasing very soon, and I'm really excited about that too, is Android support. So we're adding first-class Android inferencing support, including NPU optimization, starting on Qualcomm hardware, but we'll have an open interface where we can plug in other vendors too. And we're going to be able to allow you to run this both on mobile apps, so mobile phones, but also on IoT devices, so stuff without a screen, for example. So the Rubik Pi 3, you can already buy it from Thundercom. That is going to be our first non-phone target to build Android IoT applications. And then on the right, you'll see a FOMO ID model running directly on an Android phone. Really, really excited. We're also, and we've already shipped the first version of this, is GStreamer support. So this is a question we've gotten from more sophisticated computer vision customers. They want to build their complex vision workflows, stuff like dealing with multiple camera streams or hardware accelerated augmentation of these camera streams in GStreamer. So we've been working with Qualcomm on integrating the Qualcomm IM SDK, the Intelligent Media Multimedia SDK, into Edge Impulse. So you can build Edge Impulse projects and run them directly in Qualcomm's GStreamer interface. The preview of this currently supports YOLO v5 based models, not for the YOLO v5 head, but we're adding support for all types of models, computer vision, to start with very, very soon. You can get started already with the docs link that is here at the bottom. And as we talked about at Imagine 2024, we have been working on a model monitoring solution. Because building a model, that is not enough. You actually want to know how this model performs in the field. You want to go look back at historic predictions and go, basically say, hey, a day ago, someone flagged an anomaly, but according to the site manager, nothing was happening. Can we take a look at what happened there? Or I want to push a new version of my model to the devices that I actually have in the field. How do I do that? So our model monitoring solution that is going to solve all of these problems. Here is a initial design document of what we've been working on. You'll see here live inference events. You can, as you see at the bottom, you have a timeline of actually events that this camera has seen. You can go back in time. And we're working together with device management vendors to actually get this onto real cameras very, very soon. So if you're interested in this part, kind of closing the loop on building these models, come talk to us. We have a lot of really great ideas, especially around visual inspection use cases first and foremost. So if you want to get early access to that, or then just have a conversation with us, I think it's going to be really cool. And last but not least, model cascades. So something that we've realized over the last years of building, with customers, is that a lot of times you don't use a model by itself. A model is part of a bigger cascade of multiple models that will look at the same data, but in different ways. So examples of these are, you might have an object tracking algorithm to find new cars in a parking garage or somewhere. And then you want to go look at each new car and then run a license plate detection model over that. So that's a two-stage cascade. Or you might have an accelerometer that can run a small decision tree. And you first want to run in a decision tree, like, hey, is there actually an interesting event going on? Yes or no? And only then wake up the microcontroller. Or maybe you want to do a visual anomaly detection system first to find interesting areas and then send the message to the cloud to ask, hey, what actually is happening here? Or even like a three-stage system where you first do an object tracker to go find the object that you're interested in, then a visual anomaly detection step to find if the object actually looks correct, and then cascade to the cloud. Well, so these things are incredibly common. So here's an example of doing that with a visual anomaly detection system, right? An LLM, if I throw this picture into an LLM in the cloud, it might be able to tell me, hey, there's a soccer ball here on the floor. And in this context, that is a known. But I can't send every single frame that my camera captures to the cloud. It's going to be prohibitively expensive, and I'm going to burn through my battery really, really quickly. So otherwise, I can train a visual anomaly detection model that will be able to detect, like, hey, there is something here in the middle of this picture, but then we don't know what it is. We just know that it's an anomaly. Well, we can put them together, right? So we first run an anomaly detector on the device itself. It's really cheap. Only train a picture of the floor, and now we know that, hey, there's something that is not floor here. And then I can cascade either to the cloud, so I send this picture to the cloud, or maybe I wake up the big NPU that I have on my system. And then I'll ask, and then it will say, hey, the object within the red box is a yellow soccer ball with black pentacles. Okay, that is actually not expected. So we've been building the first parts of these cascades, and you can find them here on the GitHub link of 2 videos here. So this is a model cascade using object tracking. So here I have a prompt, and the prompt is, what color hair does this person have and what color shirt do they wear? And that's something that I'm going to ask the cloud. And I have an object tracking model, the same one that I just showed, the person detector, that will just find the new people and then ask the LLM. So I have the best of both worlds. So here I come. That is me. That person is blonde hair and wearing a brown shirt. And then my girlfriend comes in, has dark hair, is wearing a black shirt. And then when I come back with a new shirt, it will see me again and will now tell me that I have a gray shirt on. This is cool. I've only sent 3 photos to the cloud. And I got all the benefits of the LLM, right? Without having to send every single frame which I think is really cool. Like almost all of this is running locally, really fast, and it burn a little bit of energy to go ask the cloud. And we can do that with visual anomaly detection too. You can find the GitHub repository here to do the same. So here I have an anomaly detection system, and it finds stuff, but I put my arm in front of it, and I throw a ball on my floor. It's in the back here. And when I enable the model cascade, or we first look at the prompt, this image was flagged by the anomaly detection system. The anomaly is highlighted in red, etc. And the moment that I enable this model cascade, we'll now ask the LLM, and the highlighted anomaly is a soccer ball on the floor. It's great. And super dynamic. All kinds of stuff you would never expect in this system, like the plush toy here, or the person with mismatched socks. That was me, apologies. The elephant plush toy in the dress was possibly misplaced. So now we get the best of both worlds. We get a super quick, really efficient anomaly detection system running directly locally in device, but we still get all the capabilities of the big LLM, the zero-shot knowledge, actually knowing about all kinds of objects that we never expected. So I think this is super, super exciting. So we're taking a couple of approaches here, or a couple of different work streams that we do to enable these things even better, besides the repositories that we've already been publishing. So stuff that we've been working on is first vision language model support within the studio, because right now you throw the prompt in, but how well does that prompt work? I don't know, it's just trial and error. Like we actually want to go and properly evaluate that. So we're adding that. Here is a mock-up that we did for Embedded Worlds. We're also working on a cascade builder to configure these model cascades. And we really need to do that because these cascades also run on different compute architectures, right? Your accelerometer little model runs on the accelerometer. The other model runs on MCU, or one model runs on the MPU, the other one runs on the MPU, and the third model runs in the cloud. So being able to configure those cascades heterogeneously is, I think, really important. And we can do that. We're super well set up to go do that. And we already run some of these vision language models on targets, like on the Dragonwing IQ9, which we've shown at Embedded World. So you can then run these cascades actually already on the NPU. I think this is incredibly, incredibly powerful. So I know there was a lot to digest, especially at the end of an amazing day of sessions. So I'm gonna end it here. I want to give a very heartfelt thank you to everyone that has been part of the Edge Impulse community for the past 6 years. When Zach and I founded this 6 years ago, we never imagined the sheer amount of projects and the amazing stuff that you guys have been building with Edge Impulse. And with the new changes to the platform, the new features, etc., we just are so excited to go see what else you can go build with this. We're super excited. We're also adding a lot of new people. So if you're like, hey, this shit is so cool, I want to go help build this, come find us. We're hiring a lot more people going forward. And yeah, just thank you. Thank you.